Hello and welcome to the video on conditional probability. Okay, so conditional probability is a formula that comes off the formula for our non-independent events. So if two events are not independent, then the probability of A happening and B happening is equal to the probability that A happens times the probability that B happens given A happened in the first place. Okay, so what I'm going to do is just remember that these are probabilities. Probabilities are numbers between 0 and 1. So they're numbers. So I could use algebra. I could use algebra. Um, I could use algebra techniques on this formula right here because this is it's an equality sign. Okay, so you could get some good. You could learn some algebra too, some refreshers. Okay, so this part right here is actually the conditional probability. What am I doing? This is my conditional probability because the probability of B is conditional on A happening. The probability of B happens is conditional on the probability that A happens. Okay, so this is a number. So say I want to get rid of this number and move it to the other side. Since these are being multiplied, okay, since these are being multiplied, we can divide the probability of A on both sides. Okay? Now the probability of A times the probability of A, any number divided by itself turns into a 1. Okay? So now I have this over here, the conditional probability is equal to this side. I'm going to switch them around. So this is the probability of B given A equals the probability of A and B happening over the probability of A happening. So this formula is actually given on your formula sheet. And I used to teach I used to use this method and teach it all the time. But now I just use a common sense method. Okay, and it's very simple to do these. This is very similar to what we did in chapter 2. Similar to problems in chapter 2. Okay, so if you remember from chapter 2, probability given A, this was our who. We restrict who we're interested in, and that goes in the denominator. Okay, so this is the number of the who. It's how many who's that we have. It's the number of who that we have, and in the top, this is the number of successes. The successes. Okay, and you'll understand what this means. Okay, so it's the probability that we have the who's, and generally you could use this formula, but whenever I teach this formula, it just confuses students. So I'm going to show you a couple nice examples, and this one's from the book, and we could just ask a whole bunch of questions, and you'll see that I asked all these questions earlier. It's just I didn't use any notation. We were using different notation before, so if you get comfortable with the notation, you'll be fine. So boys, girls, and if you read this problem in the book, they took a stratified sample. I'm going to go ahead and pause and fill this out though. Okay, so this is the problem that some psychologists surveyed these 476 children in grades 4, 5, and 6 in Michigan. Okay, and they asked the students whether their primary goal was to get good grades, to be popular, or to be good at sports. Okay, and this is the responses they got. So I'm going to show you both methods. I'm going to show you the formula method. I'm going to show you this is the formula method, and this is the common sense. You already know how to do this. I actually already taught this method in chapter 2. I taught this method in chapter 2. You guys have never seen this before. Okay, so let's do the formula method. Now, if you look at B in this case is sports. A in this case is being a girl. So they say, so this is the probability, and I'm just following this formula. This would be, what's the probability you're sports and you're a girl divided by the probability. Now, if you look at this one matches up with the bottom one. So this is the probability that you're a girl. Okay? So I'm not saying this is difficult, but it's a lot more difficult than we did. So what's the probability you're sports and you're a girl? Okay, sports and you're a girl. This is out of everybody. This is out of everybody. Sports and you're a girl. So this is the intersection of girls and sports. So that's 30 divided by, this is out of everybody. They didn't ask for anything specifically. Divided by. And what's the probability you're a girl? So the girls are restricted. The probability you're a girl. Well, you don't restrict the girl. It's out of everybody. So how many girls do we have? We have 251 girls out of 478. So that's 251 divided by 478. And if you guys are okay at algebra, if you do a fraction divided by a fraction, this is a rule that you should never really forget for SATs and all that stuff. Fraction divided by a fraction, you flip the fraction in the denominator and multiply. 478 divided by 251. So the 478's up here cancel. That's gone because I flipped it. And I'm left with 30 over 251. So that's the probability that they're going to play a sport given it's a girl. Now this way, this is your who. That's who we're interested in. So we want to restrict that. So this would be in the boys. I'd say, what's the probability of sport given you're a girl? So the first question you say is, I'm telling you that it's a girl. So I'd say, all the girls raise your hands. Okay? Because I'm not interested in the boys. If you have the boys and you have the girls, see, we restrict their girls. So I'm saying, I'm not interested in the boys, I'm interested in the girls. So get rid of the boys. Say, all girls come in this room. So how many girls would I have in this room? So I go to the girls, and I say, okay, I have 251 girls. So this is my who. And I'd say, out of the, okay, well, how many of you girls play sports? So out of the 251, then you go to say, how many of the girls play sports? So it would be 30. So that's the quick way to do it. Okay, so let me just give you a few more to practice in this little section. So what's the probability that you want grades given you're a boy? So follow the thing that I do there, and then oh no. Okay, good. What's the probability? I want to go the other way. You're a girl given grades. What's the probability that you played a sport given you were a boy? What's the probability that you're a boy given you're popular? A few of these don't make sense. It makes sense the way that the first problem was written. Okay, so you should have this one. So you say, what's the probability that they signed up for that they want good grades given they're a boy. So I ask all the boys. So you say, well, how many boys are there? There's 227 boys. Out of these 227 boys, how many of them signed up because they were interested in good grades? 117. Okay? Now let's look at this. What's the probability that you're a girl given you signed up for good grades? Doesn't make too much sense, but what's the probability you're a girl given you signed up for good grades? So you'd say, well, how many people signed up for good grades? So good grades is down here. So these are all the people. If you add these two numbers, you get this number. These are all the people that signed up for good grades. So that's my who. So it's 247. Out of all the people who signed up for good grades, how many of them were girls? 130. So that's the probability of that happening. What's the probability you signed up because of sports given you were a boy? Okay, given you were a boy. So how many boys do we have? 227. 227. Okay? 227. Out of these 227, how many signed up for sports? 60. Okay? Restrict how many are popular. Restrict the popular. But this is the probability that you're a boy given you signed up to be popular. So this is who you need to restrict. This is who I'm interested in. So you say, how many signed up to be popular? 141 raise their hand. You take them and put them in a separate room. And you say, out of these people, how many are boys? Okay, out of 141, 50 were boys. Okay? Next chapter, when we're talking about another formula for independence, which is better than our other formula, we'll get into some analysis of these. So chapter 2, we had a rough idea of independence. Okay, just looking at these probabilities right here, the conditional probabilities, which we learned in chapter 2, which would be 117 over 227, 50 over 227, and 60 over 227. One way to think about independence is if this and this and this are sort of about the same, then they're independent, because the boys that signed up for grades popular in sports were all about the same. Okay, that would be independence. But we have a better way that probably makes the most logical sense when we deal with these conditionals, and you'll see that in the next video. So thanks for watching, and have a nice day.